At the beach in Galveston, you decide to rent an umbrella from Bella's Beach Shop. Upon asking for the cost to rent the umbrella for 8 hours, Bella pulls out a worn and wet table of prices. "Oh no, what will I do?" wondered Bella. Help Bella, be a kind person, and help Bella recreate the price list. Okay? So, what did you fill in first? So you made sure that it was 1, 2, 3, 4, 5, 6, 7, 8. Okay? What did you fill in next? So did you fill in anything here? Oh, good. Dollars. So these two were fairly clear to see, weren't they? $12.25 and $14.50. What did you notice about those? The difference is $2.25, right? What is its corresponding difference of the time? 3 hours. So what can we do with that corresponding change of y and corresponding change of x? Divide them, right? What is that? That's our slope, right? That's our change, our constant change every single time. So does that give me enough information to fill in the rest of this table? Okay, so if I know this one's $12.25, the next one should be 13. And the next one should be $13.75. The next one should be $14.50. Oh, good, it is. And the next one should be $15.25. And the next one should be $16. Is that it? Oh, I forgot to go backwards. What should this one be? $11.50. And this one? $10.75. Okay. So, what about a function rule? Do I have enough information for a function rule? Do I have enough information written down for a function rule? No, but I have enough information in my head, don't I? Okay. What is my constant change? So that's my slope. So we say, what, f of x, is that okay? Or y, either one, equals 0.75 times x plus 10. Now, 10 is not written down anywhere, so where did that even come from? That's my favorite number, so I wrote it? No. If time was 0, if I went back one more time, right? So you're telling me if I'm going to rent an umbrella for 0 hours, I have to pay $10. Okay, is that real? If you're not going to rent an umbrella, how much money are you paying? Nothing, right? But this is where we have to start computing the cost of the umbrella. Fair enough? Okay, so look at number 2. Ella's Aquatics rents umbrellas for a flat rate of $16 for the day. If you want to spend 10 hours at the beach, from whom should you rent? Why Ella? So I should rent from Ella because it's cheaper. Oops. Cheaper. If you want to rent for just a few hours, from whom should you rent? Because I should rent from Bella because it's cheaper. What's a break-even point? What's worth the same price? Where is the break-even point for this problem? 8 hours. How do you know? It's the same price, isn't it? Okay? Any questions about this worksheet? Okay? So I gave you a second worksheet called what was I trying to say? Generalizing. Okay? Somewhere on this graph right up here, we're going to be a little bit more specific before we get a little bit more general. Okay? So somewhere on this graph right up here, I want you to draw a line segment. Anywhere you want, draw a line segment. Draw it. From this line segment, I want you to find your rate of change. How many different ways is there to find a rate of change from a graph? About 12, right? Not really. There's probably like 3. Okay? But a lot. Okay? What's the easiest way to find a rate of change? Count. Rise 1, run 3. 1/3. But is that what we're going for here? What are we going for here? Change of y's over change of x's, right? So I need to know that this point is 5, 6. And I need to know that this, 5, 7. I need to know that this point is 2, 6. So the change in my y's, 7 minus 6, divided by the change in my x's, 5 minus 2. Oh my gosh, it is 1/3. Same thing I got when I counted, right? I have to find my y-intercept. How am I going to find my y-intercept? If I go down one more into the left 3, won't that extend it across the y-axis? Does that tell me my y-intercept? Not for me. It doesn't cross at an exact point, does it? So how am I going to go about finding my y-intercept? I can use this, can't I? I know a point. That's a 6. That's a 2. I know my slope is 1/3. Can I solve for b? Do I have enough information? Yes? So do this with your line, whatever your line is. I'm going to finish it out with my line. Does this tell me my y-intercept? Is my y-intercept 16/3? No, it's not, is it? What's my y-intercept? Yeah, 0, 16/3. A y-intercept is a point on the coordinate plane, so I have to write it like this, don't I? Okay. Now let's generalize. If these are my 2 points, what is my rate of change? Well, we've talked about this a little bit already. It's my change in my y's divided by my change in my x's. And according to the formula that you see in all the books, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what letter do we use for rate of change? Do you remember? M, because everyone knows that slope starts with the M or something. Maybe it was like from the Latin. Like slope in Latin is like motulo lita. Not really, I just totally made that up. Okay. What's my y-intercept of this particular graph? I don't know specifically, but I can say something in general about it, can't I? What's it look like? 0, B. Why did I choose B? Oh my gosh. Okay. Now, we're going to do an activity. I'm going to try to record it with the document camera. I've never done this before, so it's going to be a fun experience. Okay. Let me turn it a little bit more if I can. Okay. And I don't know if this is going to work, but we're going to try it. Okay, I need you to clear the left-hand side of your desk. Clear the left-hand side of your desk. Everyone knows where our left hand is, right? times the L. Clear the left-hand side of your desk. You need to be able to turn your feet. Okay, turn your feet. You need to be able to stand up and sit down fairly. Yeah, I'm looking at like this side of this. I meant left-hand side of your desk, not right-hand side. Okay? You got it? Have you ever heard of the wave before? No? Yes. Anyone ever heard of the wave? Right? Someone demonstrate the wave for me? Oh, that's like the worst wave I've ever seen in my life.
Oh, like actually
like this, right? When you're at the Rangers game when they're winning, which they just did 3 games in a row, right? Against the Braves. Seriously, they just swept the Braves. Okay? You do the wave. Now, typically, like when the person beside you is standing up, then you stand up and then like that. That's not what we're going to do. We're going to do the wave. Okay? We're going to do the wave, and I'm going to be the recorder. Okay? If you're watching the video, I know you can't see what I've written here, but I've numbered 2 to 20, counting by 2s, and that's in my X column. Okay? What is that going to represent? People, right? There's 20 people in here, isn't there? Okay? This is one of the rare occasions where my dependent value is time. My dependent value is time. Because won't time depend on how many people are doing the wave? Yes? Okay? So, Jonathan, you're going to start. Okay? You and Jamie are going to go. Did I call you the right name this time?
Yes.
Okay, good. Okay. Something about that row, I think. Okay? So, you're going to go, but you're not going to start until he sits all the way down. That's how it's going to be just a little bit different than the regular wave. Okay? And after you guys both go, we'll record your time. And then we're going to add 2 more people. And then we're going to add 2 more people. And we're going to add 2 more people, and 2 more people, and 2 more people, 2 more people, 2 more people, 2 more people, 2 more people. Got it? We're just going to keep doing it until we have our table filled in all the way. Okay? You ready? Oh, and you got to try to do it at the same rate every time, right? You want to try to be consistent in how you do it. And as soon as he does his, you got to try to do yours the same as he does. So everybody's going to try to do the wave the same as Jonathan does. Yes, sir?
I might have to do the wave one thing.
I don't know what you mean. Do you know how to do the wave?
You were just like talking about just stand up and sit down. Like stand up and then do the wave and then sit down?
Yes.
All right.
Does somebody understand what I mean by doing the wave? Would you please demonstrate for me? Cord, would you demonstrate?
Good.
Yes.
Alright,
I'm
fix it all. I'm not.
Okay? So I'm going to time it. You ready?
Alright.
Mark, set, go.
you didn't make the noise.
You're slow.
Sorry.
3.93. Okay? 3.93. Okay, ready to add you 2? Jonathan, you're starting again. Ready? Jonathan, you ready? Jonathan, you ready? Okay, Mark, set, go.
Okay, can I get like a chair instead of
Wow.
I'm not such a wide.
Okay, tell your mom, what'd you do at school today? I was in math and I got bruised. Good. It'll make you a stronger person. Okay, you ready? Starting again? Adding 2 more people. You ready? Mark, set, go.
This game sounds so good.
What?
Isabel just thought it sounded like
Hold on. Did she?
no.
What?
You just confused her.
supposed to be going the same rate every time? Okay, adding 2 more. You and Karina, ready? Mark, set, go.
Such a sad movie.
Yeah, this is very sad wave, isn't it?
Yay.
Very good, Nathan. Nathan made it more exciting. Excellent, Karina.
That's on my belly.
Okay, adding 2 more. Wait, we're here, right here. Okay, adding 2 more. Ready? Mark, set, go.
Wave sound.
2 more. You 2 ready? Mark, set, go.
Monica. I'm not ready for this. No.
16.96. Ready?
I'm going first.
You 2. John, John's gonna go first.
What?
Okay, you ready? Mark, set, go. See, now you don't need to go to athletics because you already worked out today,
I
right?
didn't start this no funny.
You didn't even write it down. Your hands up.
Adding 2. Luke, Tanner, ready? Jonathan, go.
Still don't understand why we're doing this.
Whoa! You didn't see him.
We gotta restart. Sit down faster. You're not doing the same.
You didn't do it the same.
It's not that hard. You wait till people down and you know.
Hayden's doing it different each time.
Go straight down and do class.
Well, I thought you rested.
Yeah!
No, they didn't do it, so I didn't.
24.7.
It's gotta be a weight rush. I was at the last one to go.
It was the last one.
Okay, ready, Jonathan? Adding 2 more. Mark, set, go.
Yeah, last.
Jonathan is the most excited person.
Oh my gosh, you like their pause and
Don't judge people's way. Don't judge people's way.
you punched me and then you'll just did it like really good. After myself that she's doing it, I know, like wow. It's really weird doing something and watching yourself do it. I know.
Alright, now later we gotta
28.25. Alright, last one. You ready?
I don't.
Last one. Adding 2 people. Ready, go.
Hayden better do it right this time. Oh, I'm stuck. I'm stuck. Well, I'm stuck. Why you go so slow, Nathan? Nathan went fast. It's scary. I wasn't sitting down. Shame. I'm laughing at you in the face.
Hey!
Loud noises. Loud
Yeah, you that's what I did the first time.
You just sat on the side.
30.67. So, what kind of data did we just collect?
Apparently 14 just 4 seconds.
What kind of data did we just collect?
How long has someone did it away? Average of about 2 seconds.
Should it be a particular kind of data? Should it be a particular kind of data? What kind of data should it be? should we take approximately the same time to do the wave every time? So what kind of data should it be? Yes? It should be linear data, should it? Okay. This is not stable for a reason. You'll see why in just a second. Make sure you get 2 pages. How many of you have ever seen a situation where the time depended on something else? Let me see if I can zoom in so whoever's watching the video can see the data. I don't know if I can or not. So that's the data that we got when we did our time. Okay, so what I need you guys to do right now is readjust the chart that's on the front of this paper that I just gave you called the wave. Readjust this and fill in the number of students and the time. I know you're going to have to scratch out some numbers. Get over it. Do it anyways. Yes, start with 2. Okay? So get it copied down on your paper. Any of you guys ever seen a situation where the time was the dependent variable? Anybody? Is the time the dependent variable in this problem? Didn't the time depend on how many people were doing the wave? Yes. Okay, so this is what I'm talking about when I say I want you to write it down on your paper. Zoom out a little bit. Focus. Oops. 10:41, 12:30. What is it doing? It's just mad at me, I guess. 10 is 14:10. 12 is 16.96. 14 is 20.01. 16 is 24.73. 18 is 28.25. And 20 is 30.67. Okay? So you have this table copied down. I know you're not going to end up using it because the chart we need to make is on the back. So unless you want to keep flipping back and forth, that's why I left the table on the board. Okay? So we need to make a graph of our data. We need to do the proper things with this graph, though. What are the proper things before we even start? X and Y. Okay? Hopefully you see the X and Y axis already darkened for us because all we're dealing with is positive values here. So the x-axis is across the bottom of the page, the y-axis across the left-hand side of the graph. Okay? How are we going to need to count on this graph? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it only goes up to 16, so I can't count by ones. So probably twos. What else needs to go down there? The label, right? The word. What is it representing? It's representing people or a number of students, I guess is what it says on the front. Okay? How are we going to count on the y-axis? By twos again? How much does it go up by? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it only goes up to 19 on the y-axis, so is twos okay for that one as well? 16, 18, 20. Okay. So now I need to plot these points on my graph. 2, 3.93, which is almost 4. 4, 7.2, which is ish. 6. Now, can I plot exactly 7.2 on my graph? So why did I say ish? Because I want to get it as close as I possibly can, right? I don't want to put it down here when that's really 6. I want to get it close to where it should be. Okay? So 6, 10.41. 10 is, 8 is 12.3. Oh, I skipped a number. You guys didn't even tell me that. 14, 16, shut up. 18, 22, 24, 26, 28. Wait, are you telling the person that you put in the hospital to stop coughing? Okay. 8 is 12.3. 10 is 14.10. 12, 16.96, so almost 17. So right there. 14 is 20, basically. 16 is 24.73. So almost 28. 24.73 is almost 25 is what I meant. 18 is 28.25. And 20 is 30.5, so maybe like right there. Once you have all your points plotted, I'm going to bring you a mathematical device which you will not eat. And I'm going to have you put it on your paper, something like this. How did I put it on my paper? It's like a trend line, right? It's as close as possible to all the dots that are there. Mine's probably a little bit too high because of these dots right down here. So maybe like that a little better. And then I'm going to take some tape and tape down my mathematical device. Again, without eating it. Okay? Alright, I'm going to bring you a mathematical device. Okay, do you have your mathematical device taped to your paper? Okay, so we need to answer the second half of this. Now, do you see why I didn't staple them together? And thank you for calling my attention to the fact that we messed up on something. What did we mess up on? We didn't label this, right? What should it be? Time? Okay. All right, so look at this, the paper that's with it. Place a strand of spaghetti. Okay, we already did that. Calculate the slope between 2 points. We got to find 2 points on this line. Okay? Find 2 places where the spaghetti is crossing right at the intersection. Do you see that that is one of my places? Do you see how it's crossing right at that point? And do you see how mine is crossing right at that point? It's not the point of the data, it's right where it's the fact that the spaghetti is crossing right at that point on the graph. Does that make sense? Okay. So my 2 points are 812 and 1624. Now, your points might be different based on where you put your spaghetti, and that is okay. All right? That is okay. So I'm going to put my spaghetti paper aside for a second. How am I going to go about finding the slope? Change in y over change in x's. My change in y's is 12. My change in x's is 8. So that means my slope is 3/2. Does that make sense? Okay. What's the real world meaning of the slope? What's the labels that go with the slope? This is the change in y over the change in x, right? What label goes with y? Time. What label goes with x? People. So, second per person? It's the second per 3/2 second per person? What does that mean? So if I make it a little bit more easy to understand, 1.5 seconds per person. I don't know why I wrote per. P-E-R-S-O-N. Per person to do the wave. Right? So if I have to find my y-intercept, what's my y-intercept going to be? Can I just count my y-intercept? 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Where's my y-intercept? 0, 0. Is everyone's y-intercept going to be 0? Answer these 2 questions right above where it says calculator. Answer these 2 questions and we'll talk about it tomorrow. Okay? Have a great day.